Okay, so let's deal with the upper section of the river, the section between Taupo and Hamilton, the section that I say is dominated by the hydrolakes. Let's break that down into bits. The first bit that we talk about is between Taupo and the area at Iraki-Karako. So from Iraki-Karako pretty much down all the way to Karapiro, and we're talking about 150 kilometres as the river flows. That section is that series of hydrolakes where the water is held back. People have done the calculations and they think that before the dams were built, water used to flow from Taupo down to here in Hamilton in maybe 2 or 3 days. But since we've built the dams, the water's being held back. That same parcel of water that used to take 2 or 3 days now takes more like 5 weeks. So, and in that 5 weeks it's sitting there in the hydrolakes, and the algae, the microscopic plants, have got all this time they can grow, and so their numbers increase quite dramatically. There's 5 or 6 times more algae in the river at Karapiro than there is in the first lake at Lake Oakuri. So there's been quite an amount of growth of algae. That's where the water gets its greenness from. In that upstream part of the river, algae grow in the hydrolakes. Algae are tiny microscopic plants. Huge numbers of them, you know, 1 million in a litre of water. We can't see them, but they do give the water that green, murky appearance. So the 3 main types of contaminants we're concerned about: nutrients, bacteria and sediment. In the hydrolakes we're most concerned about nutrients. The reason we're not concerned about the bacteria in the hydrolakes is by and large they seem to die there. We've got these large expanses of water exposed to the sunlight, kills the bacteria, and they settle to the bottom in the water that's not moving. We're not concerned particularly about sediments either, because the geology of this Upper Waikato catchment is such that the water, the rain falls and the water just goes straight down into the ground. There's not a lot of erosive runoff that we might see in other parts of the region. The water just goes straight down into those freely draining soils and doesn't take a lot of the sediment with us. So in the hydrolake we're not particularly concerned about sediment. We're not particularly concerned about bacteria. The nutrients, however, support the growth of the algae. So the nutrients that enters the hydrolakes, the water in the hydrolakes, comes from 3 main sources. Now, there was nitrogen and phosphorus entering the rivers 100, 200 years ago anyway. There's natural sources of nitrogen and phosphorus, and we mustn't forget about those. For example, every time the lightning, there's a strike of lightning, that's where nitrate is created in the atmosphere. There's nitrogen gas in the atmosphere. A bolt of lightning combines that nitrogen with oxygen and you get nitrate, which falls in the rain and enters our waters. So nitrogen and phosphorus are naturally present in the water anyway. The other source of nitrogen and phosphorus in many parts of our river system is discharges from point sources. For example, discharges of sewage or from factory wastewaters. In the hydrolake section there's really only one main discharge of wastewaters. That's the discharge from the Kinleaf pulp and paper mill, and there is some nitrogen and phosphorus added to the water entering the hydrolakes from that point source. No substantial sources of sewage or industrial wastewaters, however, to the hydrolakes. So that leaves the 3rd main source. The 3rd main source is runoff of nitrogen and phosphorus from areas of land that we've developed for farming. You can compare the amount of nitrogen, for example, that comes off a hectare of native bush or pine forest, and you compare it with what comes off the same area, say, of a dairy farm. They differ by more than a factor of 10. There's more than 10 times amount of nitrogen comes off from an area of dairy farm than does from the area of native bush. We've got quite a lot of farming in the catchment of the hydrolakes, both dairy farm and sheep and beef, and so there's this additional loss of nitrogen and phosphorus from farmland, and those losses are increasing. Farming is becoming more intensive and larger areas of the catchment have been developed for farming, areas that used to be, say, in pine forest in the past. So those are the main sources of nitrogen and phosphorus to the hydrolakes. So I know people say things like, my farm is miles away from the river, how can it be affecting it? And I agree, it does seem strange. I know when I go out and stand on those farms, I think, gosh, you know, isn't it amazing how the water is travelling underground all that distance, underground or across the surface, and eventually reaching the river. And what we do know, because we make measurements on areas of farmland, we know that any area of developed land loses certain amounts of nitrogen and phosphorus to the groundwater and thus to the rivers and streams every year. And that combined effect of that over the whole of the catchment shows up in our monitoring results. We make our measurements at the bottom of the catchment and we can see the combined effect of all those losses. So the water is moving underground, moving down the streams and eventually finding its way from the tributaries into the river.
The second section of the river from Hamilton down to Port Waikato is quite different to the first section containing the hydro lakes. It is unimpounded or free-flowing.
From here down, the greenness is still there, but we've got this muddy appearance as well. Probably the most important new contaminant that's entering the river between here and Port Waikato is sediment. And much of the sediment that we see in the river, in this lower section of the river, comes down the Waipa catchment, joining the main stem of the Waikato River at Narrawahia. And the reason there is so much sediment coming in down the Waipa is twofold. There is the geology of the Waipa catchment is much softer than the geology of the Hydro Lakes catchment. And rain and soil erosion contributes large loads of sediment into the Waipa River. It rains heavily, the soil erodes and is washed into the river, and we see this large pulse of sediment added to the lower river. The other reason we get a lot of sediment coming down the Waipa, interestingly enough, is there aren't any dams. One of the things the dams do on the Waikato River is they trap a good proportion of the sediment that is washed out of that pumice country. We don't have the dams trapping sediment on the Waipa, and so there's a larger load of sediment to the lower river from the Waipa. The absence of dams on the Waipa also means that the loads of bacteria to the Waipa and thus to the lower Waikato River are also higher. We don't have those hydro lakes where we have natural die-off of bacteria. So in the lower river we have a totally different appearance, and it's appearance that's dominated by soil erosion, and the water is brown and murky as a result.